We have been working in section 4 and section 3 in chapter 4. Solving quadratic equations by factoring, solving quadratic equations using square roots. I tried to review all of that with you on Friday. What I'm going to do today is I'm going to leave section 4 for a little bit. We're not done with it. But I'm going to leave section 4 and I'm going to go to section 7 and show you the last way that you are shown how to solve a quadratic equation. So you'll have 3 different ways to solve a quadratic equation after today. Factoring, square roots, and now the quadratic formula, which we'll learn today. They don't all work. Only the formula works every single time, all right? So it's a really important formula to know. He will solve every single quadratic equation that will ever be thrown at you, all right? What's up? So this problem that I'm going to ask you to solve by factoring, yeah, it could be solved using the quadratic formula, but I haven't taught you that yet. Always works. Always works. But again, I don't suggest that you don't use factoring when it can apply, because factoring will make it easier, believe it or not. Go ahead, Chris.
Oh, yeah, that's that.
Oh, yeah. No, I just think when you're in the middle of a pre-calc problem next year and you have to solve a quadratic at the end, trust me, factoring, if it factors, will be the way to go than throwing in the quadratic formula. But it would work. It does solve everyone out there. So what I want to do right now is let's solve this one by factoring. Get back into the swing of it, see what the 2 answers to this equation are. Then this is going to be the first problem that I ask you to solve using the formula. So that you're going to see it gets you the exact same 2 answers. The formula works. It does solve every single quadratic equation. All right, so guys, if we were going to solve this by factoring, first thing you got to do is get everything on one side set equal to 0. Is that done? Beautiful. Do you like the order it's written in? X squared, X, just number? Great. So first we would look for a what when we go to factor? GCF. Does a 2x squared, a 5x, and a 3 have anything in common? No numbers, no variable. That means we're going right to the factoring process. We know whatever we put in the first 2 spots has to multiply to who? Who can we lock in right now? Who's only going to multiply to a 2x squared? A 2x and a 1x. Beautiful. Now, whatever number I put here and whatever number I put here has to multiply to who? 3. And then my rainbows have to multiply and add up to who? Negative 5x's. All right, well, guys, the good news is when we start putting in numbers to multiply to 3, who are the only numbers in this world that multiply to 3? 3 and 1. So those are your only options. But just be careful. If you put a 3 here and a 1 there, that could work. You're going to get a 1 times x, a 1x, a 2x times 3 is 6x. Could they add up to the negative 5x's that you need? Potentially, but will they be then, with the signs you need to do this, will you be able to multiply to a positive 3?
Yes.
No, because you're going to need a negative and a positive to go to a negative 5, right? And will a negative and a positive multiply to positive 3? So that ain't it. So maybe we got to switch them, and we got to try the 3 here and the 1 there. Let's see what we get. 3 times x is 3x. 2x times 1 is 2x. Could they add up to negative 5x's? Potentially. What signs do you need them to be to add up to a negative 5, but yet still multiply to that positive 3? Both negative. All right, and then that would work. Then everything does its job. All right, so we factored it, but we're not factoring. We are solving by factoring, so we still have to solve. But by factoring it and breaking it up into pieces that multiply, look what the problem says now. It says this times this has to multiply to 0. The only way 2 things multiply to 0 in math is if somebody is a who? 0. Somebody's got to be 0. So it's either this factor who ends up equaling 0, or it's this factor who ends up equaling 0. So let's find out our answers. What's it going to take in order for 2x minus 3 to become our 0? Add 3, and then divide by who? 2, and x will be 3 over 2, which is about 1.5. So 3 halves is one of our 2 answers to this degree 2 quadratic equation. But then what does x need to be in order for x minus 1 to become our 0? X needs to be 1. And there's your second answer. So those are the 2 answers that are going to make this quadratic equation true. They are also the x-intercepts of this graph. This parabola is definitely going to cross over the x-axis at 1 and 1.5. A was positive, so his parabola is opening up. It looks something like that. That's what we know right now. Okay, so now Factoring, unfortunately, not all quadratic equations are going to factor into these beautiful factors. Not all the answers are always this pretty. So we need another way to solve a quadratic equation in case factoring and square roots don't work. That's going to be the quadratic formula. The good news is, guys, it's literally a formula. All you have to do is plug numbers in and let the formula create the answers. It's just, unfortunately, not the nicest looking formula, but we'll be all right. Take one of those. Now, normally, you guys are in a bad spot. You do this in Algebra 1, so you would have already have seen and practiced the quadratic formula. However, I have spoken to your Algebra 1 teachers, and nobody got to factoring or the quadratic formula when COVID hit with you guys. So you are a little bit, this is the first time you're probably going to be seeing it. Okay?
Wait, it's like everybody taking pre-calc in here?
It depends if people choose it or not. Some people will not take a math next
I
year.
feel like I'm the only person who chose to not take math.
No, it's
I took pre-calc.
Oh, yeah.
Wait, Miss Hardy,
Yes.
when do you go to guidance?
What's up?
When do you go to
I think they did all the scheduling already.
They didn't go, we did.
Yeah, I was like,
I don't know then. Maybe they didn't.
No, it's just like, you just hang out there. Yeah, it was due like a month ago.
No, you can't leave. They're supposed to close it out, give them one.
And then they finalize all your your choices and whatnot. You're probably fine.
Yeah.
They're not going to let you leave this year without a schedule set.
Okay, because I'm not taking a lot.
No, I would definitely, don't be afraid to pop in and make sure you guys on the same page as your guidance counselor. All right, here we go. So we are jumping to section 7. This is going to be the third and final way that I teach you how to solve a quadratic equation. Guys, when we were solving linear degree 1 equations, they were so simple. There was only one way to solve them. You get x on one side of the equal sign, you get numbers on the other. Degree 2 equations are more complicated, so it would make sense that there's more than one way to go about solving them. All right, so here is a quadratic equation in standard form. Ax squared plus bx plus c. We know there are two answers to a degree 2 quadratic equation. They come in like different kinds of answers though. If you're going to get two real different answers when you solve for x, that means it's a parabola that crosses over the x-axis at two different real numbers. You might get the same real number twice. Maybe you get x equals 2, x equals 2. That just means he really only has one x-intercept, and that x-intercept is his vertex. That's what happens when you get the same answer twice. Or now we know you might get two imaginary answers to a quadratic equation. And that just means that the parabola is either entirely above the x-axis or entirely below. It doesn't have any real x-intercepts. But those are the kinds of answers we can get. Two reals, the same answer twice, or two different imaginary numbers. We have already learned how to solve a quadratic equation by factoring. We've already learned how to solve a quadratic equation using square roots. Now we're finally going to learn the third way, the quadratic formula. And the quadratic formula, guys, it works every time. It is the only method that can solve every quadratic equation out there. So I have students that say, Hardy, I'm just going to remember the formula and I'll use it to solve every single quadratic equation. And you could do that because it always works. But I'm telling you, when you're in the middle of a problem next year that you've worked really hard just to get to a quadratic equation and you have to solve the quadratic now, factoring might be your quickest and best bet than having to whip out the quadratic formula. So sometimes it's just factoring saves you time because it's quicker and easier, but the formula works every time. All right, so what's the formula? What does it look like? Oh, you know it.
Plus y equals mx minus.
Okay, no, that's linears. All right, let me just warn you. So, how did the quadratic formula come about? Well, a mathematician a very, 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 very long time ago was solving quadratic equations and putting a lot of time and effort in because they didn't have calculators back there, and basically thought, wouldn't it be nice if there was a way that we could just literally solve every quadratic equation using this process? So he took standard form of a quadratic equation. He used A, B, and C to represent the numbers that go in front, the coefficients. He just left them as A, B, and C. He didn't give them an actual number. If A, B, and C were any number, what would this equation equal? And then he proceeded to solve this for X. He tried to get X completely by itself on one side of this equal sign. Now, I'd love to show you, but it takes a process called completing the square that you will learn next year, and I hope they show you. But otherwise, They got x alone, and it then became known as the quadratic formula. And when you get x by itself, it says that x will always be equal to
Negative B.
the opposite of b, negative b, plus or minus, because you are going to be taking the square root of something, which creates two solutions, plus or minus the square root of b squared, subtract 4 times a times c, and then all of that, the entire right side of the equal sign, gets divided by 2 times a. And your job is going to be able to be plugging numbers in for A, B, and C, and then creating an answer. So if you're sitting here going, well, who the hell are A, B, and C? A is always going to be the number in front of the x squared. B is always going to be the number in front of the x. And C is always going to be the constant, the number by itself at the end. You just pop them in and simplify that. Again, obviously that's not the easiest formula to plug into and simplify, but that will solve every single quadratic. Go ahead.
Hard. The only hard part is kind of
No, this is it. Memorizing it and then this part. Otherwise, everything basically does itself. And again, Darren, I have had students that literally will always use the formula, and it works. The problem is there's going to be questions in the future where they're going to say, factor this or do this. So it's not like factoring just gets to get thrown out because now you know the quadratic formula. Factoring is still used for other things. All right. Now, what was I just going to say?
How do you listen to a calculator?
What you can't. So we're going to take it in stages. So just know that this formula will work every single time. So if you're going to solve using the quadratic formula, here are the steps. You get everything on one side set equal to 0 in the correct order, just like you would if you were going to factor it. You don't want to start picking out who's A, B, and C if you have things on both sides of the equal sign. So you're going to get everything on one side set equal to 0. Identify A, B, and C, plug those numbers in for A, B, and C, and then simplify. We know we never leave fractions that are not reduced, and we never leave radicals that are not reduced. So we're going to have to reduce and then see what our final answers are. And then this will get us your 2 answers. It gets 2 answers. All right, let's give it a whirl. So guys, go to the first example on the back. It is the exact same question as your warm-up, except now we're not going to solve it by factoring. We're going to solve it using the quadratic formula. And we're going to see how we get the exact same 2 answers. The formula works.
Another answer.
All right, 1 3/2, right?
Yeah.
All right, let's see. Is everything on one side set equal to 0?
Yes.
Yes, so we're ready to go. Who is A if A is always the number in front of x squared? 2. I always like to kind of identify him and write him. Who is B if B is always the number in front of x?
Negative
-5. And who's C if he's always the constant at the end? 3. Beautiful. All right, our job is to plug them into the quadratic formula now. I think that you should be writing it down every single problem you get to, because the more you write it, the easier it is to memorize, because you do have to memorize it, all right? So now x will be equal to the opposite of b plus or minus the square root of b squared, subtract 4 times a times c, all divided by 2 times a. Now, if anybody had Miss Abrahamian, I know she usually would give her students like a song, I think to the music of Hickory Dickory Dock, that kind of helped memorize this formula. I don't know it, nor do I ever sing in front of people, but I was always told about Xavier. Xavier was a negative boy who couldn't decide to go to a radical party or be squared. He missed out on 4 awesome chicks, and it was all over by 2 a.m. Listen, I don't know if you're ever going to memorize that, but if any little part of that helps, that's what I remember being told. And it's too bad, but listen, just if it helps. All right, here we go. Let's plug in. So x will be equal to, first we need the opposite of b. Who is that according to what we wrote down? Just 5. And then plus or minus the square root of, all right, now we have to plug b in and square it. So who's b? -5. So I suggest whatever you plug in for b and square it, always put b in parentheses. Whether he's positive or negative, always put him in parentheses when you square. So -5 squared, that's b squared. Then you're going to subtract 4. You're going to times it with a, who is 2, and you're going to times it with c, which is 3. And then all of that, the entire right side of the equal sign is divided by 2 times a, which is 2 times 2. Everybody take a peek and just make sure you're everything in the right place. All right, now, if you don't have a calculator, go grab one. I want everybody to feel this. I want everybody to do it on their own. Your phones are garbage. Do not use your phone calculators. They are horrible.
It's already.
What?
I thought you couldn't drink it.
Say it?
I thought you couldn't put it into the calculator.
Oh, you can. Oh, it won't do the whole thing. We're going to do it in stages.
This is fire, dude.
Miss Hardy, I have a TI 30 calculator. Is that better or worse?
TI better than worse than a what?
It's worse. It's less.
30s are okay.
It's worse than this one.
30. This is a nice calculator. 34.
I have my own calculator.
The next nicest thing would be the 36. All right, here we go. So what I think you guys should do, because normally when I teach the quadratic formula, it's the b squared minus 4ac. That's actually called the discriminant. B squared minus 4ac is called the discriminant of the quadratic formula, and he can tell you a lot about the kind of answers you're going to get. We'll get into that later. But normally, that's the part of the formula that students don't get right. They cannot get b squared subtract 4 times a times c to become the right number. So I think you guys should do this. Everybody, rewrite x equals 5 plus or minus the square root. What I want you to type into your calculator is everybody get a clear screen, clear your calculator.
What did you just do?
I just rewrote 5 plus or minus the square root. Now take your calculator and clear it. Don't have anything on the screen. I do not want you to put the square root yet. No, clear screen. I just want you to type in this stuff. What does the number under the square root become? What does b squared subtract 4 times a times c? So you should literally be typing this into your calculator right now and hit enter. I want to know what number that becomes.
Shouldn't the 5 be positive though?
What's that?
It's negative b.
Take the opposite.
Only the opposite of b is here. Here is just b.
What?
Only the opposite of b leads the formula, but under the square root, it's b who you're squaring.
One.
Who did you get? It's 1. So that means you will be taking the square root of 1. That's what we have right now. And then it's going to be divided by who's 2 times 2. So that's what I think you should do every time. Just find out who b squared minus 4ac becomes. Then we'll tackle the whole square rooting thing. All right, now we're going to go x equals 5 plus or minus. Guys, this is beautiful. It's a best case scenario for us. Who's the square root of 1?
1.
It's 1. It's a number whose square root we can take. So we get 1. And he's not under a square root anymore. And then it's still divided by 4. So if you are able to take the square root of this number, take it, and now you're left with this. How many answers are we supposed to get to this degree 2 equation? 2. And what does our warm-up tell us that should be? It should be 3/2 and 1. It's the same problem as the warm-up. So now because the square root went away, there is nothing stopping us from moving forward and breaking this up into 2 scenarios. The first scenario is going to be x will be equal to whoever we get when we take 5 and we add it with 1 and then divide by 4. So first we're going to take 5, add it with 1 and divide by 4. Who's 5 plus 1? 6 divided by 4 does not divide, but who does it reduce to?
2.
Which is exactly the same answer we got from factoring. 3/2 is one of our answer, 1.5. And then for the second scenario we're going to play out, our second answer will be x is equal to, now we're going to take 5, but this time we're going to minus the 1 and then divide by 4. So what is 5 minus 1 going to be? 4. And what's 4 divided by 4? And there's your second answer to this degree 2 quadratic equation. And it's the same 2 answers that we got by factoring. So this is just a quadratic equation that has multiple ways it can be solved. In the future, I would say, guys, I'm solving that by factoring. But quadratic formula always works. Go ahead, Chris.
So how come, so let's say you make a test, are you gonna ask us to back?
Probably, I mean, on the next quiz, I could probably say solve this quadratic equation by factoring. Is there anything stopping you from doing the formula? No.
Wait, so
No.
So I can do.
You can do whatever, I'm telling you, you can do whatever you want. To me, it's more important that you can solve and get to the answer. However, just know that there are going to be problems in the future where factoring is the only option. So if you think, oh, this is my way around not having to know how to factor, we're going to use factoring for other problems other than solving quadratics. So it's still a skill you have to know. So I think you'd be silly to not want to keep your factoring up.
But how do I know when to factor?
I always try factoring first. And then if you're sitting there, Chris, and you're like, God damn it, there are no numbers whose rainbows work, then it probably doesn't factor. And then you have to go to the quadratic formula. So unfortunately, with factoring, if it doesn't factor, you may have wasted a lot of time trying to find those factors, even if you were never going to find them. And then a student can argue, well, I should have went right to the formula. So if I try factoring and I don't get it within a minute, then I just go to the formula. All right? Yeah.
On the test,
Yes.
are there gonna be problems where we can't factor?
Yeah, probably, because I'll probably make them quadratic formula problems. We're going to review. You're going to be very prepared.
So we have to memorize it.
Yes. Unless I'm in a really good mood that day, Jake, and I write it on the board. I don't know. I can be a bitch on wheels, man, all right? Here we go. Let's try it again. We're going to...
Most likely you will be.
I don't know. We'll see. All right, so here we go. The more we go through the process, the easier this gets. And guys, I'm telling you, write the formula down every time, because by the fourth example, you'd be surprised how much of the formula you already have memorized. All right, if we're going to solve this using the quadratic formula, everything has to be where? On one side set equal to? We don't have that yet, so let's get the 3 out of the way and over to this side. I do have a number that I can combine him with. So now we're going to have 25x squared minus 20x and then plus 4 equals 0. Perfect. All right, now can I say this? If this was a factoring problem, what do you always look for first with factoring? Okay, guys, this problem does not have a GCF. For giggles, though, pretend he had a GCF. Pretend this problem had a GCF of 4. You took it out, and you're like, I know that's not, I get it. We're pretending. All right? Pretend that this worked. Now, you are still allowed to do this even if it's a quadratic formula problem. You can take the 4 out, and now you can use this as A, this is B, and this is C instead of using A, B, C. And we're all going to get the same answer. Somebody can use this as A, this is B, and this is C. And then somebody else can use this is A, this is B, and this is C. And we're all going to end up with the same answer, except the person who used the smaller, easier numbers for A, B, and C, they're going to have less simplifying at the end of the problem. Somebody who used the bigger numbers for A, B, and C are probably going to have some reducing to do at the end. Which, hey, we'll all get to the answer. But I'm telling you, if there's a GCF, taking it out, you're allowed to use the smaller quadratic expression as A, B, and C, and then it does make for a nicer problem. Now, if you forget, no big deal. No big deal. But if you are still looking for GCFs, oh my God, it does make the quadratic formula nicer and smaller numbers to work with. All right, well, luckily for us, this one doesn't have one, so we don't even have the option. So who is A in this problem? 25. B is negative 20, and C is beautiful. Let's plug it into the formula. Let the formula do all the solving. So the formula says x will be equal to the opposite of B plus or minus the square root of B squared, subtract 4 times A times C, all divided by 2 times A. All right, here we go. So x will equal, who's the opposite of B here? Just 20. Plus or minus the square root of, now you got to plug in B. Who's B? Negative 20, but put it in parentheses. I don't care if it's positive or negative. Always put B in parentheses when you go to square so your calculator doesn't mess it up. Then we're going to subtract 4. We're going to times it with A, which is 25. We're going to times it with C, which is 4. And then all of this, the entire right side of the equal sign gets divided by 2 times A, which is 25. Woo! So if I'm you guys, you got to go to that B squared. What the heck number does B squared minus 4AC become? So we're going to say x equals 20 plus or minus the square root of who? Do not put the square root in yet. Just punch in the B squared minus 4AC part, hit enter, and see what number you will be taking the square root of. It's not a trick. It's a beautiful number. You can. See if you can get it. Make sure you feel it. Don't just watch and make sure everybody else gets it. Make sure you can get it. Who'd you get? 0. and then it's divided by, what's 2 times 25? 50. Now again, this is another best case scenario. I'm just going to continue. X will equal 20 plus or minus, guys, who is the square root of 0?
0.
It's 0. You can take the square root of 0 and get 0 back. So you get 0, and there's no more square root. You took his square root. And then it's going to be divided by 50. Since the square root went away, there is nothing stopping you from moving forward and working out both of these scenarios. So one of our two answers will be what we get when we take 20, and let's add it with 0 and divide by 50. So 20 plus 0 divided by 50. Guys, what's 20 plus 0?
0.
20. And then divided by 50. The zeros cancel, and what fraction are you left with? 2/5.
Same answer.
It is, Jake. So now the beauty of getting a 0 is when you go to do the second scenario out, now we have to take 20, but this time we have to subtract 0. But guys, whether you add or subtract 0, don't you get the same number? Yeah, so you're still going to get 20 on top again, divided by 50. My zeros cancel, and what fraction are you left with again? 2/5. So this is a degree 2 equation who does have two answers. It just happens to be the same answer twice. So technically on Delta Math, all you'd have to type in is 2/5. You only have to type it in one time. But if you're like me and you like to see two answers to a degree 2 equation, it's 2/5 and 2/5. But you only have to type it in once. And then that tells us his parabola, it touches the x-axis at 2/5, but that's the only time. And he opens up since A was positive, so he must be a parabola whose vertex was an x-intercept, okay? It only touches it one time. All right, how do we feel? Everybody okay? Because these are the best that it's ever going to get. Because the next two examples are going to be ones where the square root does not go away. And then you have to just make sure you're simplifying. All right? All right, we're doing great. Let's go. Let's go get example 3.
What is the normal average on this test?
Not bad.
Really?
No. All right, here we go. If we're going to solve this by the quadratic formula, or even factoring for that matter, where does everything need to be? Set equal to what? 0. So let's get the 15x off to the other side. I don't have any x's to subtract him from, so he's just going to have to stay minus 15x. Let's just make sure we put everything in the right order. Who should I write first? 4x squared. Who should come next? Minus 15x. And who should be last? Plus 10, and now it equals nothing, which is 0. Okay, I would look for a GCF. If you could take a GCF out and get a smaller number for A, B, and C, do it, guys. It does make your life easier in the end. But unfortunately, there is no GCF here. So A will be who? 4. B will be negative 15, and C will be 10. Let's plug them in. Let's see what we get. X will be equal to the opposite of B, plus or minus the square root of B squared, subtract 4 times A times C, all divided by 2 times A. Okay, X will equal, who's the opposite of B? Just 15, plus or minus the square root of, now we gotta plug in B, who's B? Negative 15, but put them in parentheses, so we include the negative when we square it. Then we're gonna subtract 4, it's just part of the formula. We're gonna times it with A, who is 4, and then times C, which is 10. All right, all over 2 times 4. Go right to that B squared minus 4AC, figure out what number you will be taking the square root of. But don't take the square root yet. What does that B squared minus 4AC become? What'd you get? 65. You should get 65.
I got.
What'd you get?
Well, now I'm putting there. It's the same.
What?
I got 2,400.
No. Did you just type in this? In parentheses, subtract 4, use the subtraction for the 4, and then parentheses,
Wait, what was it?
Yeah.
65.
Okay.
Yeah, that's right.
Why is
Try it again.
Like what?
All divided by 8.
Like why
Now-
is this NCP?
All right, here we go. So now let's go back. Let's evaluate the square root. We are left with the square root of 65. Can you take the square root of 65?
Almost.
No, right? Can you simplify the square root of 65? Any number you can take a square root of, divide evenly into 65. No. So guys, it may not feel like it, but you're done. You can't take the square root of them. You can't take them off to the side and simplify them and put a simplified answer back in. I mean, you would if you could, but we can't. So when you look at that, I can't do anything with that square root. Then you start looking at the fractions. Guys, everything on top is being divided by 8. So can 15 be divided or reduced with 8? No. If anything simplified here and broke out, then you'd be fair game to reduce any number in front of him with 8. But there's nothing there. So none of your radical simplifies, none of your fractions simplify. This is your finished answer. That is your exact finished answer to this problem. Now, Delta Math will let you type it in just like this. 15 plus or minus the square root of 65 all divided by 8. If you want to separate them, one answer is when you take 15 and you add it with the square root of 65 and then divide by 8. And then your second answer is if you took 15 and subtracted the square root of 65 and divided it by 8. Now, everybody pick up your calculator. I don't want you looking at this like it's Chinese lettering. It's not. This is literally just an ugly decimal. So everybody clear your calculator screen, take 15, hit the plus sign, then hit square root and put in 65 and hit enter. 15 plus the square root of 65, guys, is 23.0622577. It's just an ugly decimal. Now, finish it, hit divide by 8. And you get 2.8827822219. This is about 2.9. If you had to graph it, you'd put a dot where x is 2.9. This one, it's just an ugly decimal. Take 15, subtract the square root of 65, and you get about 6.937742252 divided by 8, and you get about 0.86721778. It's just about 0.9. But we don't want you rounding your answers. So you leave them in their exact simplified form, which is this. Sorry. But at the end of the day, guys, they are numbers. And they're numbers that you know. They're just ugly, ugly decimals. All right, let's do the last one. Let's see what happens when we get an imaginary answer. What's that going to look like? Because there is a square root built into this formula. So you might take the square root of a negative number, and now your answers are imaginary. You all right, Jake?
No.
Deep breaths.
Wait, why couldn't you simplify it?
What do you mean? Because you can't take 15 and add and subtract it with the square root of 65 because he's an ugly decimal. 15 doesn't divide by 8. Nothing in front of this radical divides by 8, so there's nothing to simplify.
So if that was like, there was like a 2 under the square root.
So, no, if there was a 2 in front, then you would be 15 over 8 stays because they don't divide, and then plus or minus 2 over 8 is 1/4, and then you could simplify that to the square root of 65 over 4. I'm going to get into that tomorrow a little bit.
Okay.
All right, here we go. Last one.
Are we gonna have homework tonight?
I promise. Do 2 today and 3 tomorrow. All right. Is everything on one side set equal to 0? Yeah. Now, guys, normally when you get answers like this, the ones with the radicals that don't go away, those are the ones that never would have factored. Those are the ones that would not have had nice factors, and you would have wasted a lot of time trying to find numbers that work, because they don't. We would never have been able to create those from factors. All right, let's look at this one. Is everything on one side set equal to 0? Yeah. So A is 2 here. 2. B is -6, and C is 7. Let's plug it in. X will be equal to the opposite of B plus or minus the square root of B squared, subtract 4 times A times C, all over 2 times A. All right. Who is the opposite of B? Just 6. And then plus or minus the square root of, now you got to plug in B. Who's B? -6, and we're going to do what? Square. And then subtract 4 times, who's A? 2 times C, which is 7. And then it's all, the whole thing is going to be divided by 2 times A, which is 2. All right, go to that B squared minus 4AC. What number will we be taking the square root of? So X will be equal to 6 plus or minus, just type in this to your calculator. No square root, just type in that. And what number does it become? -20. So you will be taking the square root of -20. Uh-oh. The square root of a negative number is definitely going to result in an imaginary solution. All right, and then it's all divided by 4. So what you have to do, at the very least, everybody has to take the square root of -20 off to the side, and we have to fix him. What is always the first thing you factor out of a negative square root? -1. So we're going to break it up into the square root of -1 times the square root of +20. Who is the square root of -1? All right, that's showing us that we now have an imaginary solution. All right, now, we're either going to take the square root of 20, we're going to simplify the square root of 20, or we're going to leave the square root of 20. Can you take the square root of 20?
Yes.
No. Can you simplify him?
Yes.
Who's the biggest number you can take a square root of that divides evenly into 20? 4. So we'll break it up into the square root of 4 times the square root of, who's left over? 5. Yes. Then we get I times, who is the square root of 4? 2, and then the square root of 5.
Wait, there's eyes now?
Oh yeah, because if you take square root of a negative number, you're going to get an imaginary. Because he's the number I can take a square root of. I always put that one first. All right, so now I times 2 is 2I times the square root of 5. That is what we want to put in for this. So take out the square root of -20 and put that in his place. X equals 6 plus or minus 2 times I times the square root of 5, all divided by 4. Okay, now here's the annoying part. When you go to reduce your fractions, this is what I want you guys to do, because this is going to hopefully help you not make a mistake. Guys, if I asked you, what's 10 plus 15 divided by 5? What's 10 plus 15 on top? 25. What's 25 divided by 5? The answer to that is 5. However, since everything on top is being divided by 5, you are allowed to split it and divide everything in the top by its own 5 first. What's 10 divided by 5? 2 plus what's 15 divided by 5? What's 2 plus 3? 5. It's still the same answer. So that's what I want you to do here. Take 6 on top and divide them by his own 4. This is crucial. Delta Math's going to make you do this. Then you're going to have your plus or minus in the front, in the middle. Now take 2 times I times square root of 5, divide him by his own 4. You're just taking the pieces in the numerator and giving them their own separate denominator, so we can deal with them one fraction at a time. So now, what does 6 over 4 reduce to? 3 over 2. Plus or minus, since this is all attached by multiplication, I am allowed to reduce my fraction. What does 2 over 4 reduce to? 1/2. So 1 times I times 5 is I times 5 over who? 2. That's how you can get away now with reducing your fraction. So all you're doing is splitting. Give everything on top its own denominator of 4, and then you deal with one fraction at a time. Now, let me just show you this, because last year students came in yelling at me that they did not know how to type their answer into Delta Math, that Delta Math was a huge problem. So, look at this one. I'm not going to make us do it. Let me just get the answer from Delta Math so we can type it in. -17. All right, everybody look up here. Just watch me. This hopefully will save you some time on your homework. All right, so let's say you had to solve this problem. You get everything on one side, set equal to 0, you do the quadratic formula, this is your answer. This is what students were doing last year. They started typing in, using their keyboard, -17 they used the plus or minus sign, they used the square root button, they put in 73, right hour over, then they hit the forward slash for a fraction, right?
No.
But it only puts part of it. So what I suggest you do is this. See how it's 17, I get it's negative, but see how it's 17 over 6? I think you should type in 17 forward slash 6. Make the fraction. Get a fraction started. Now I'm going to use my up arrow and my left arrow to put the negative sign in front so it stays in my numerator. Then I'm going to use my right arrow and I'm going to hit my plus or minus, my square root, my 73, and that's what I think you should do. Just start a fraction, something over something, then you use your arrows to go around and start moving things around. Otherwise, students were saying that it wasn't letting them make the whole thing a fraction.
Even more.
All right?
Have a great afternoon.
Use the fronts, that's fine. I'm just saying without them, this is what I would do. Just get a fraction started.
What did you even say? We didn't discuss that.